Hi and welcome back to ACL Stands. In this episode we're going to take another look at this HMV transistor radio here. I got this off a neighbour, so I've had it for a fair few months and I really need to get this back to him. There was a part 1, you can go check that out. In that video I suspected that it may have been a transformer issue. I'm starting to not think that is the case, but I guess we're going to find out. So I'm going to open this up and let's have a look inside. So I put the speaker back inside the unit, connected it up. I really don't want to be running it without some sort of load. So there's a number of things that I've replaced, and I've got a bag over there of all the components that I took out. Before I start doing anything else here, I'm going to go back over this unit with my magnifying glass. I'm going to see if I can find anything at all, because it's always good to come back after a long amount of time and re-inspect it. There are things that you do, initially that is not always right, so it's always good to come back and double check your work that you've done. So what I'm going to do is just quickly go over this. So originally I diagnosed this unit as having nothing. There was no signal. You could sort of hear a bit of static when you turned it on, but there was absolutely nothing coming through the speaker. Since that first video, I've actually got myself a signal tracer, which is up here. So I'm going to be putting that to use, and it's really handy to have one of those because if you want to diagnose audio circuits. I also have in the background there, you can see a little oscilloscope which I picked up really cheap on special, and this is just great for looking at audio signals, or it doesn't have all the bells and whistles of like a desktop oscilloscope, so it's just purely for audio stuff that I'm going to be using it for. We've got a few things going on, and something I've discovered. Well, a couple of things I've discovered. First of all, there is a capacitor. They're kind of like the film type capacitors, those sort of squarish ones. And there was a leg that wasn't soldered properly, and I only picked it up when I went over it a second time with the 30 by magnification. The leg itself was actually really camouflaged, and it was sort of bent over close to this chassis, and it was really hard to spot. I've resoldered that up. So since the first video that I made, I've actually gone and built a few of these little 9-volt power packs. So these are great because these work in the old radios. They're really easy to build. There's a couple of videos actually on YouTube if you want to go and check out how to do this. You've got these old radios, and these are definitely a must-have and super easy to do. And I don't know if you can hear that. I'll put the microphone up to the speaker here. This speaker's pretty damaged.
Southwest of Western Australia and southern.
But we are getting signal. So we pretty much went from this thing not working to at least we're getting some sort of signal. It's distorted. A good indication that this isn't the transformer, which is what I suspected it might have been. So the next thing we need to do is figure out why we are getting distorted sound on the output. Okay, before I go any further, I need to go back and check all those components that I replaced, because most of those components, there's probably nothing wrong with them. And I would like to have the original stuff back in here. I'm thinking that I maybe didn't look at those color codes correctly because they are faded. So I've got this Rangemaster schematic here. So as I suspected, I actually did make a mistake, and I've gone and put 470 ohms instead of the 4.7k. So looking at the schematic, this was resistor 27, which is here. There's also another 4.7 that I actually had to replace as well. So if the resistance value is not correct here, this could attribute to distortion in the circuit. So I've gone and replaced those and put the original ones back in. So the next thing I'm going to do is a quick voltage check of the circuit. I'm going to go through on these schematics here, and you can see all the values are listed. So this is really good. It's going to give me a great indication of what the voltages should be at certain points in the circuit. So I'll try and get all this in frame if best I can. So we should have whatever the load is on those batteries. It's 8.43. We should have 3 of those across there. That's fine. we should have 8 on there. So if we go through to the OC 169s here with 6.8 minus 0.7 minus 0.5. A little bit less because we've, the batteries are a little bit weaker, so 0.7. That one should be 0.5, I think it was. Yeah, so that's fine. So what I'm going to do is I'm just going to go through all these transistors and check those out, make sure they're all the right voltages, and then I might just do a quick check of the capacitors, and then I'll come back. So all the voltages check out. Now I've gone and replaced another resistor. I pulled one out and there was a lot of variation in that resistor for some reason. So I've gone and just put a resistor that I've had here and made sure that I had the right value this time. Now if anyone's wondering if this thing wasn't tuned, then nothing's been touched on the tuning side of things, so the distortion has nothing to do with that. Let's power this thing up and fingers crossed that this is going to work. So we're still getting distortion. Okay, we've got a bit more volume now. Now you can still hear that that's distorted, but that's the speaker. So for me to test this out, let's connect up the signal tracer. So we're on the volume pot here.
You to communicate with each other, connect up and create.
Let's connect to the output.
There's a very long story behind the origins of the telescope. It goes back perhaps to what.
Okay, so that sounds pretty good. It was about halfway volume there, so signal is still a little bit scratchy. I think that might have something to do with the tone control as well, because this actual axial capacitor here has come off. If you can see that on the video. I'll zoom in a little bit. You can see it's supposed to be connected to the chassis there. But now there's still a few things to do on this. The light needs to be fixed up. It's actually on all the time. I don't really want to run that light constantly. It's meant to be sort of momentary. They type of lamps there run from like 3 volt to 6 volts, so I don't really want to be chewing up the power. After that, really the final thing to do is see if I can track down another one of these roller speakers. See if I can get some specs on this, otherwise I'll have to put it on the meter. But okay, so it's the next day. I need to get this finished as quickly as I can because I really want to move on to some other things. 37 degrees here in Australia, so it is absolutely ridiculously hot. Okay, so I've got a few things to do next. The first thing I want to do is I'm going to remove this whole chassis here from the front of the casing, and to do that you've got 4 screws, 2 at the bottom here, 2 at the top. I'd probably suggest maybe using a bit of hot glue or something, and what I ended up doing was just connecting a extension wire off this here and then just connecting it up here onto one of these connections off the chassis, which seemed to solder much better than the actual chassis itself. So the lights need to be fixed up and returned to its momentary setup. So the actual plastic spacer broke, so if we're just going to zoom in here, so if you have a look just here where I'm pointing at, this is a little plastic spacer that I 3D printed. The original one actually cracked in half, and what it had was a little rod inside it, and this was isolated from the top screw. It's just top screw just up on the top here that runs down. And it needs to be isolated because otherwise, if you just put a bolt in there, when you connect this power wire here to the bolt, it's actually going to be grounding on that chassis. So you need to have an isolated spacer, I guess would be the terminology to use. And what I've just done is used a 3mm screw and screwed that into the actual spacer, and then the spacer has been screwed into the original screw at the top. So essentially it just has a 4mm hole at the top comes down through the spacer. It's filled in so the two screws can't touch. This worked really well. What I ended up doing is replacing the wire that came off this potentiometer here, the power, and I ended up just winding that around that screw and then using a little bit of hot glue to secure it in place. So the replacement resistors that I put here in the part 1 of this video was really just to replace those parts and see if it fixed the issue and we got signal through the unit. I've since removed all those resistors because these particular older radios have what looks like, I guess, 1 watt resistors, 1 or 2 watt resistors. So if you're going to get replacement parts for these older HMV radios, probably look at like the 1 watt or 2 watt resistors variety. So obviously the speaker is going to sound a little bit distorted because it had a lot of rips and tears in it, unfortunately. So I could probably go and source another speaker for this, but at this stage I really don't have the time to go looking for another one. Turn this around. In front of the unit here, you can actually see that mine is broken. It's supposed to be connected here and here, so those two sections are broken. I'm just going to have to use a little bit of epoxy there to fix that up. Also, the speaker you can see looks really terrible there. I've just actually used tissue paper and PVA glue here just to fix it up as best I can. Give this front face a good clean. So there's a look at the radio all cleaned up. I ended up putting a little bit of hot glue under here where it was broken, and I ended up putting a little bit of hot glue just up around just up in the corners, and then we've got our little battery pack here. So I'm going to go ahead and put the back on this thing. So that's where I'm going to end it for this video. Overall a successful repair. Still a little bit of distortion in the circuits, very minimal, but I can still sort of hear it a little bit, and I'm not sure, maybe it has something to do with those OC169s or possibly another one of those resistors cracking up, but not working before and working now, so that's a huge step. And hopefully it's the last one of these that I see, but I'm sure that I'm going to get a lot of questions maybe in the comments. Anyhow, thanks for watching. Hope you got something out of it. I'll see you on the next project.
Just talking to them, not even in their memory. But I remember Eric himself that Aussie.